We'll begin talking today about correlational designs. We'll cover this content in 5 parts. First, what is correlation? Then, how do we measure it? How do we interpret it in part 3? In part 4, there are some cautions to be aware of. In part 5, we'll talk about nonlinear correlations, and in part 6, complex correlations. So, what are correlational designs? So correlational designs answer the question, do two factors correspond or relate to one another? Do two factors vary together? And so the example in the little illustration, if students missing the most classes get lower grades, the suggestion is that there's a causal relationship between attendance and overall performance. So there's a relationship. We might look at these questions for a correlational design. Is there a relationship between age and happiness? Does relationship longevity correspond with level of pain during breakup? Do the number of work hours a person has relate to the time they spend studying? Is there a relationship between the length of someone's hair and their level of courage? So there might be and there might not be, and that's the kind of question that we're answering. Do these two variables change together? Correlations are made with continuous or ordinal variables. So variables that have some sort of sequence attached to them. Either they're continuous, meaning values can be anywhere along a continuum, like age, for example, or they're ordinal, like even though they look like names, they actually have an appropriate sequence, like year in high school, freshman, sophomore, junior, senior. And so below you'll see a list of variables. The only kind that really aren't suitable for a correlation are nominal variables, variables that just differ by name, and it doesn't matter the order that they're placed in. So you can identify, if you look closely, a few variables here that differ just by name, and the order in which they were placed wouldn't matter. So age, average happiness on a scale of 1 to 10, eye color. Of those 3, we can see that age and happiness both have a numerical ranking. Age, of course, is continuous. The numbers can fall along a continuum of values, and average happiness values can fall anywhere between 1 to 10. But eye color, that's just a color. It doesn't matter if we list blue first or brown first or green first, black first, it doesn't matter. And so that's a nominal variable that would not be suitable for correlation. Continuing down the list, number of people living in one's home, grade point average, years of education completed, pairs of shoe owned. These are all variables that have numbers associated with them, and so they all would be appropriate for correlation. Favorite movie, however, would have words associated with it, like titles of movies, and usually we don't do, in fact, we can't do correlations on those kinds of variables. Height, average hours of employment per week, hours of alone time per week, job type, part-time versus full-time. And you can see there that categorized in that way, job type would be a nominal variable. The other ones all have numbers associated with them. They would be appropriate for correlation. Number of Facebook friends, preferred note-taking, handwritten versus typed, and level of introversion. And again, of that last cluster, handwritten versus typed would be nominal and not appropriate for correlation. So correlations can be positive, in which the values vary in the same direction, such as when one variable increases, the other increases. And these are called positive correlations. For example, the relationship between exercise and heart health. So if you can picture exercise on this first arrow going up, I'll put the E. I won't put the E. I thought I could write. And if you can picture the other upward arrow as heart health, you can see that as exercise increases, heart health is likely to increase. Not for every individual, but as a trend looking at a large number of data points, likely. Meditation consistency and coping skills. As meditation consistency increases, picture that on the first arrow, coping skill is also likely to increase. And screen time and eye fatigue. As screen time increases, eye fatigue may also increase. Now notice these arrows can go up, very upward in the same direction, very downward in the same direction. The key point here is that they vary together. When one increases, the other increases. When one decreases, the other decreases. Correlations can also be negative or inverse, such that when one increases, the other one decreases. So variables can vary in the opposite direction, such as when one variable increases, the other decreases, and these would be called negative or inverse correlations. And for example, the relationship between study hours and social time. As study hours increase, social time is likely to decrease. You know, you have to take that time from somewhere. Not for everyone, not for every individual, but as a general trend. Stress and well-being. As stress levels increase, sense of well-being is likely to decrease. And the number of years dogs live as strays and the lifespan of those dogs. As the number of years dogs live as strays increases, their lifespan is likely to decrease. There can also be variables that have no correlation. They don't vary in the same direction, they don't vary in the opposite direction, they just don't really have anything to do with each other. So for example, the relationship between arm length and depression. If we measured arm length for a bunch of people and levels of depression for a bunch of people, we probably would not see much of a relationship, if anything at all. How about the relationship between the last digit of your phone number and friendliness? So everyone's last digit is something between 0 and 9, and does that have anything to do with how friendly that person is? I think we'd all agree that it doesn't. There's a zero correlation. And how about the relationship between the miles you have on your car and your relationship satisfaction? And by that word relationship, I mean your intimate relationship, your marriage or partnership. And we probably think that the number of miles you have on your car has little or nothing to do with how satisfied you are with your relationship. So correlations made with continuous variables, and in this case, I'm asking you if you can identify any two variables from this list that you would predict as having a positive correlation. And as an example, I think that introversion and the number of hours you spend alone each week is likely to vary in the same direction. So as your level of introversion increases, so will the number of hours you spend alone each week increase. Can you see any more that would have a positive correlation, just meaning they walk side by side in the same direction? So next, I ask you to identify any two variables you would predict as having a negative correlation, meaning that as one increases, the other one is likely to decrease. And so my example is hours of alone time per week and number of people living in home. I think that as the number of people living in your home increases, your hours of alone time is likely to decrease. So can you see any others that might be like that? As one increased, the other might decrease. And finally, identify any two variables you would predict having a zero correlation, just they have nothing to do with each other. And I put on here the number of pairs of shoes owned and the number of Facebook friends. I just really don't think that those two variables have anything to do with each other. Can you detect any of these variables from the list that you think are unrelated or have a zero correlation? So in what situations do we use correlational designs? Well, I've identified a few here. The first is situations in which an experiment cannot be done because it would be unethical. And I have two examples. The first is smoking in pregnancy. We couldn't randomly assign pregnant women to either smoke or not smoke and then assess their infant birth weight. I mean, that would be just terrible. Could you imagine being in that study and you're asked, now you start smoking a pack a day, and the next person, you don't smoke any, and the next person, you smoke a pack a day? Of course we can't do that. Very unethical, and people wouldn't agree to participate. But correlational designs allow us to examine this problem without violating people's rights and well-being. Childhood trauma and mental illness. We would not randomly assign some children and expose them to trauma and others not to have trauma and then measure their mental illness. Of course not. That would be horrific. And so we couldn't study that through an experiment. A correlation would be the only thing we could do. Situation 2, there are some situations where it would be impossible to conduct an experiment. For example, if we're interested in knowing whether age has anything to do with aggression. Maybe we think aggression is likely to decrease as people get older, and we can't randomly assign people to be a certain age. Okay, you be 42 and you be 25, you be 19. No, it doesn't work that way. It would be impossible. So a correlational design will allow us to examine this relationship. And finally, the third situation in which we might use a correlation is when we're exploring very new phenomena for which we wish to know whether there's anything worth exploring. So, for example, maybe we're interested in whether there's any relationship between having a robotic companion and loneliness. Well, we could do an experiment. We could assign a robotic companion or not, but that might be kind of expensive right at first. So we might begin with a correlational study to see if there's anything going on that's worth investigating further. Screen hours and nearsightedness. Well, screens, the ubiquity of screens is fairly recent, and so studying that through a correlation might be a good starting point. So when you think about your own studies, think about whether a correlation might be necessary for any of these three reasons. So try it. For each of the following, what is the likely direction of the relationship? How about coffee consumed and trips to the bathroom? And if you thought positive, I would agree. As coffee consumption increases, bathroom trips are also likely to increase. They're varying in the same direction. How about alcohol consumed and social awareness? I think this would be negative. The more alcohol you consume, or as alcohol consumption increases, social awareness is likely to decrease. Number of pets owned and length of pinky finger. And if you thought those have nothing to do with each other, I would agree with you. This is like a zero relationship. There's not likely to be any systematic covariance correlation between these two variables. How about level of happiness and job satisfaction? I would say this is a positive relationship. Once again, not meaning good, but just meaning they would vary in the same direction. So that as job satisfaction increases, happiness is also likely to increase. Number of pets owned and annual veterinary bills. I think this is positive. As the number of pets owned increases, vet bills are also likely to increase. And how about this? Level of caring for the earth and littering. And I think negative. The more you care for the earth, the less likely you are to litter or to take it out of the individual situation. As level of caring for the earth increases, littering is likely to decrease.